Object-oriented concepts. Understanding object-oriented concepts, classes and objects. We are engaging in object-oriented programming. We have used the term object, aka instance, and class so far in our discussions. And earlier we gave the analogy that objects, otherwise known as instances, are like individual Lego bricks, whereas a class is like the definition of the shape of a brick. But let us now dispense with that analogy, apt as it is, and talk about these concepts in programming terms. So what is a class? A class is all of these things. A class is a data type, just like any other data type in our language, such as numbers, string, or employee. A class acts as a factory which participates in the construction of new instances of that data type, of that class. Classes are actual entities in our software solution. They are created by programmers using the syntax of whichever object-oriented programming language we're using. Classes are an abstraction that model real-world entities, as described to us by subject matter experts, SMEs. Classes can be reused at runtime to create as many instances or individual objects as necessary. That is what a class is. An object is all of these things. It is an instance of that class. Hence, we often refer to objects as instances. Each instance is a runtime entity that is allocated its own memory and preserves its own state. Each is of the same type, and the type defines its characteristics. The class helps to generate and initialize each instance as it is created. The details of doing so, of course, are language and runtime specific. So to summarize, a class defines a new data type. It defines the characteristics, the list of data attributes, the methods that instances will have. An object is an instance of the class and has its own unique copy of the data. For example, the employee class says all employees are a subtype of person. Each inherits name and birth date from person, along with various methods. The employee class then adds employee ID, department manager, and salary as new characteristics of the instance. So since Bob and Sally are both instances of employee, Bob and Sally each will have their own values for name, birth date, employee ID, department manager, and salary. The class gave us the list of those things, and the instance holds the values for them all. Here are some other simpler examples of a type and an instance. Pay rate, we're told, is a floating point type. Employee name, we're told, is a string. Emp1, we're told, is an employee. Defining a class is language specific, but in concept, classes represent new types in our software solution. And in many object-oriented programming languages, each class itself is an instance that represents an instance of a class, of a type. So we can query things about classes themselves. What methods do you have? What attributes will instances of you have? It depends on the language, what inspection you can do of objects that represent the class. But the characteristics are going to be defined in a language-specific manner, although regardless of language, we can generally identify some common characteristics, which would include descriptions of the data or attributes that each object will have, definitions of the methods that will be common to all instances of that type of that class. Now, there are more advanced things, but these are common and sufficient for our introduction to object-oriented programming. When you take a class on Java, such as LearnQuest's Core Java Specialization, or a class on any other object-oriented language, you'll learn what can be done with that language and its object-oriented programming model. Now we'll have a quick little demo on classes and objects.